classifying triangles. We're going to start out, we're going to label ABC. Okay, a triangle. First of all, that root word, it's tri. And then another word, angle. What does tri mean? 3. And then angles. 3 angles. And the rays that make those angles, they come together to form the sides of the triangle. So it has 3 sides. Okay. And it has 3 angles. And the angles are also called vertices. Okay? With a triangle, we use the word vertex and angle interchangeably. We call the angles the vertices. Okay? Now, to name a triangle, you are always going to use 3 letters. Always. Okay? Always going to use 3 letters. So for this example right here, we're going to make a little triangle shape, and then we're going to say ABC. Okay? And then most people in the math world, when they name the triangle, they use alphabetical order with the letters. Even if the letters are like random out of the alphabet, they're not next to each other, like ABC are, okay? Then they'll still go in alphabetical order. All right, so now when you classify angles, you have options. 3 acute angles, and you can see them. I have an acute angle here, an acute angle here, and an acute angle here. Okay. That is called an acute triangle because all of the angles are acute. In the next one, just like in your warm-up, you have 1 obtuse angle. So this is an obtuse triangle. By the way, I don't like to write the word triangle. I like to use the symbol. I know that means change when we're doing slope, but I also use triangle to write the word triangle. So feel free to do that yourself. Okay, you can write that instead of saying triangle. Okay, right here I have a 90-degree angle, yes? So this is a right triangle. And then when your triangle has 3 congruent angles, when all of the angles are the same, that is an equilateral. Equiangular. Equi meaning equal, and angular. Okay, equiangular, so equal angles. That's what that word means. Okay, and then right here, we're going to take this lovely picture right here. This picture has a lot of triangles in it. It has, first of all, it is a big triangle. Then it's got 1 triangle here, 1 triangle here, 1 triangle here, 1 triangle here. Then it has another triangle there. Then it has another triangle there. Then it has another triangle there, and so on. There's lots of triangles in that diagram. So we're going to have to go through right here, and we're going to go look and see. So we're going to look at the letters. This says C, D, E. Okay? So C is here. D is here, E is here. So I'm talking about this triangle right there. Okay, so what kind of triangle is that? That is a right triangle. That's all you have to write down. Okay, so right triangle. The next one, B, C, and E. So we follow the letters. B to C, C to E, and then back. Okay, what kind of triangle is that? Fantastic. That is obtuse triangle. Okay. How about the next one? A, B, and E. We go to A to B, B to E, and then back again. What kind of triangle is that? Equiangular. Okay, then we have another one. B to D to E. Now let me get this highlighter. I'm going to do this one. I'm going from B to D, D to E, and back again. What kind of triangle is that? Yes, it is obtuse. And then finally, C, F, and E. What do you think? Acute. C is here, F is here, and E is here. Acute. So that would be this one. All right. Very nice job. And that was part of what you had to do in your Delta math. Does that look familiar? Okay. Okay. Next, we're going to go classify our triangles using sides. Now we're going to use the sides of the triangle. We don't care about the angles right now. We just care about the sides. So, I have a triangle that has 3 sides that are congruent. That means they're all the same. Equilateral. So we write the word equi, and then we write lateral. Us mathematicians, we're so creative. We come up with the best names ever, don't you think? We're just so creative. Actually, not really. We call a spade a spade. That's an equilateral triangle. Nothing fancy. What about this one? Y'all remember what that's called? It is isosceles. You know how I remember that? How many eyes do you have? You got 2 eyes, right? Look at that. That's how I remember it. Okay? Feel free to draw on your triangles. It is isosceles. You have 2 eyes. They are technically equal to each other. I'm sure if we analyze them, they might be microscopically different in size and location, right? One eye higher than the other, etc. Also, this triangle has 2 sides that are the same. Just 2. So isos, right? And then celes. It has 2 E's in it. It has well, it has too many S's, but it has 2 E's in it. And that stands for eyes, right? Look at me making a story. 2 E's for eyes. You have 2 eyes, 2 sides. I could go on. Okay, now, this is my favorite. Right here. No sides are congruent. You have that side. You have that side there. They're different. And then you have this side here. They're different. Anybody know what we call that? Scaling. Okay. Now, I don't have a really funny story for that one, but what I can tell you is I kind of think of it like it's 3 different, it's like having 3 different scales. You know, like I can double something, triple something, quadruple something. To me, when I look at this, I see a scale of 3 different numbers. That's essentially what you're looking at, 3 different numbers. I don't have a great story, so maybe if you come up with one, you can let me know. Okay, now we're going to do this again, but now we're only classifying by sides. So we have J, K, M, as in math, J, K, and M. Just kidding, math. Okay, what kind of triangle is that? That is scaling. Okay. How about K to L, KLN? That's this one here. Okay. How do you know it's isosceles? Yep. Okay. And then our final one, JKN. That's this one. What is that one? Equilateral. Okay, so you know how all year we've been making these little tick marks on sides, and we've been making the little angle like this, like we've been doing this, right? We've been making angle marks. We've been making side tick marks and all that. This is especially why it's important that you have those symbols on your pictures. So every time you have a picture, I need you to do that. Label all the things that are the same or different. Okay, so this right here, we're just going to do this little part right here together, and then we're going to move to the next thing. This is usually what we have you do the most. You give it a first name and a last name. Okay? The first name would be the angles, and the last name would be the sides. Okay? Right? So if it's triangle, John Doe, John is the first name, Doe is the last name, right? So we're going to name these first by angles and then by sides. This triangle right here, I'm going to look at the angles first. What does this mean right here? It's a right angle, so that's a right triangle. And then what do these lines mean right here? Okay, so what are we going to call that? We're going to call it a right isosceles. You are correct. Right isosceles triangle. Has a first name and has a last name. Just like you. Okay, we have number 10. Okay? Number 10. What's the only thing you know? Okay, I see an obtuse angle. Now, do you know anything about the sides? It is scaling. Why is it scaling? You don't have any indication about the sides. You have no info, right? You just know that it is obtuse. That's what you know for sure. I don't know if any of those sides are the same or different or whatever, so I have to call it scaling. Ooh, number 7. I'm sorry, not 7. 11. I was looking at the side. What are we going to call that? Yes. Equiangular. Equilateral. I know that has like a big first name and a big last name. By the way, little foreshadowing here, every single equilateral triangle in the universe is also equiangular and vice versa. Every single one. Okay? Just so you know. Number 12, what would you, well, I don't know, what do you think? Do we want to do 12 through 14? Okay. 12 through 14, what would you call that? An acute what? Okay. Acute scaling. All right. What would you call the next one? It's real easy to decide if it's scaling because you don't know anything about the sides. Okay, what do you know about number 14? Yeah, obtuse isosceles. You guys did that so well. How many of you find triangles comforting? Anybody? It's usually one of the first shapes when you're little that you're like, oh, that's really cool. I think triangles are comforting. By the way, fun fact of the day, The triangle is the most used structural shape in construction because it is the strongest. I think some of the science classes might ask that question too, just so you know. Okay? If you're ever asked that question, triangle is the strongest. All right. I want you to flip to this page. We're going to skip it. We are doing 3.2 right now, but I don't want to do this exploration. I have a quicker one. So I need you to go all the way to this page right here. And then I want you to watch the screen. I'm going to show you something. Okay, and before I forget, do you see this? I will put that link in the Unit 3 folder in Schoology so that you can go play with that on your own. And you actually should really do that. It's very helpful. Okay. What is that? What is it? Oh, okay. Are we sure it's a cube? No. We don't know. Let's just super basic. What shape is it? What shape is it? Triangle. Okay. That's all you know about it. You know 3 angles are different. Okay. I really don't know if that is obtuse or not. And I really don't know if those are scaling sides or not. You can't assume in geometry, but for the sake of argument, let's say it's a scaling triangle, okay? So here's my little triangle. How many of you remember how much these angles add up to? The ones on the inside. Okay, I hear a 360, I hear a 180, 90. Okay, I'm going to show you a magic trick. Now I could use my little handy dandy scissors, or I could just tear the paper, but I used an index card, so I'm going to use scissors, and I'm just randomly, I cut my triangle. Okay, and then if I take all 3 of my angles and I set them next to each other, I make them sit adjacent. I do not have a linear pair because that's 2. Okay, this is a little trio of triangular angles, right? I cut them up, put them next to each other. Ooh, those, that's the S word. What is it? Supplementary. Very good. That's your favorite word in math classes, supplementary. They add up to what? 180. They add up to 180 because they make a straight line. So this little demo right here, every single triangle in the universe, every single one, what does it add up to? 180 every single time. The sum, right here, of the measure, and I actually want to clarify this, put like a little arrow right here, and I want you to write the word interior. The sum of the measures of the interior angles of a triangle is 180. Every single time, no matter what. I don't care what triangle you're given. Okay? So, let me show you what your geometry looks like when you apply that. Okay, I have this triangle right here. This arrow right here is telling you that that angle is 24 degrees. This is 37 degrees. And then I have angle 1. They want me to find the measure of angle 1. I don't know it. So what do I know? I know that angle 1 is x. And then I have another angle that is 24 degrees. I have another angle that's 37. And all three of them together have to add up to 180. Everybody agree with that? Okay, so I should see this when you're doing these questions. And then I do want to have you actually show me what sum this is in case you make an error. I can help you faster. So that would be 61 if you add those together. Okay. And then finally, and I know you can do this last step with your calculator, but this last step you are subtracting 61. And I know that step can be done in your calculator. So, bless you, how much is x? How much is angle 1? Okay, it is 119. Now, doesn't this look like an obtuse triangle? It looks like it, right? And I know I tell you not to assume anything, but does that sound reasonable? If it looks obtuse and you get an obtuse number, is that reasonable? I think so. Okay, we're going to come over here. We're going to do this one. Ooh, it has some algebra in it. I'm going to show you, again, the little trick I like to do to combine like terms. However, okay, what do you know about that angle right here? That is 90. Okay, so right here, I have 2 x's and 5 x's. I can combine them. How many x's is that? 7. And then I have a positive 1 and a positive 5. How much is that? 6. And all of that, oh, I have to have the 90. Ooh, I almost made a mistake there. Woo! Caught it. Plus 90 equals how much? 180. So do you see what I did? I combined like terms visually. That might be really helpful for some of you who are still struggling, because I don't know about you, but that right there can make a student feel really uncomfortable if they're not confident in their ability to do algebra. So we can make it a little simpler by combining like terms visually, yes? Now, what can get combined? The 90 and the 6. So 7x plus 96 equals 180. Then what do? Then you subtract 96. So 7x is equal to 84. And then we divide by 7. And what is x? 12. So x is 12. Now that's not the angle measure. If I wanted to find the measure of this angle right here, what would I do? Plug it in. 2 times 12 plus 1 more. That's 24 plus 1. That'd be 25 degrees. Ooh, so let me ask you this question. If this one is 25 degrees and this one is 90 degrees, how can I get that one? There's 2 ways I can do it. What's one way? Oh, there's 3 ways we could do it. Smart cookie. Okay, I'm just going to walk you through the 3. We're not going to actually do it. If this is 90, what do these 2 have to add up to? They have to add up to 90, right? So I could do 90 minus the 25, and that would give me this one. I could do 180 minus 90 minus 25. That would give me this same one. Or I could just take the 12 and go plug it in. Okay, do you see how there's 3 different ways to get your third angle? Okay. I'm going to stop right here. I'm going to stop right here. Tomorrow, we're going to start out with this exterior angle theorem. if you want to make tomorrow super easy, go home and look that up. Go watch a video. Okay? But what you're going to do right now, okay? Your Delta Math, there are 2 parts to the new one. Some of you still have to do yesterday's. So you have double homework. Some of you just have today's, but I need to show you what I want you to do. There's 2 parts and I only want you to do one of the parts.